Hello students, today we will be learning about how to find maxima and minima using sridharacharya method of any quadratic polynomial. So let's first understand what is a quadratic polynomial. So a quadratic polynomial is basically a polynomial of the form ax square plus bx plus c, where a is compulsory not equal to 0, otherwise it will be a linear polynomial. Okay, so a is not equal to 0. This is called the general form of any quadratic polynomial. Now let's say that ax square plus bx plus c is equal to any value which is y. What we are going to do is, this implies take a common, so we will be left with x square plus b by x plus c is equal to y. Now what we will do is, we will look at this two term, we look at these two terms. Here we have square of x, then we have a number b by a and square of the number, and the number whose square was there earlier. Now what we need to add in this to make it of the form a square plus 2ab plus b square. So first we need to do is, first we need to have 2ab here and then b square, because a square is matching with x square. So what we can do is, we can rewrite it as a into x square plus 2 into b by 2a multiplied by x. This much we can do. Now still, now here we can say that here we have a square, we also have 2 into b into a, but we also need this b square. So what we will do is, we will now try to add b square here. How we will do is, we have b which is equal to small b by 2 small a. So we will use that 2 into b by 2a multiplied by x. Then we will multiply, add b by 2a, square of b by 2a, and since we have added a square of b by 2a which was not earlier in the equation, so we also need to subtract it with the same b by 2a square, so that we have nothing different in LHS overall. So now our equation becomes plus c is equal to y. Okay students, so far we have not done anything, we have just modified our equation to have a square plus 2ab plus b square. Now what we will do, we can rewrite this as x plus b by 2a whole square, and then we are left with minus b by 2a square, and we have a plus c is equal to y. Okay, so we can say that we have here, we can say that we have here this much. What we have here is a into x plus b by 2a whole square minus b square by 4a plus c is equal to y. Now we can say that now we can say that we have broken down the equation into a number a and a square of another number minus of b square by 4a plus c. Now let's say we want to find the maximum or minimum value of y. So of course, since we have a square of x plus b by 2a, so square of any number is always greater than equal to 0. And now there are two cases. If a is greater than 0, then we will have, if a is greater than 0, then we will have something called, let's say a is greater than 0. Okay, let's say we have, now say a is greater than 0. This implies a into x plus b by a whole square will also be greater than 0, because this number square, let's say this number is k, so k square is always greater than equal to 0. And if a is greater than 0, this number will also be greater than equal to 0. Now to make y minimum, therefore to make y minimum, we need to have a into x plus b by 2a whole square equal to 0. Now since a is not equal to 0, therefore x plus b by 2a whole square is equal to 0 need to be there, and therefore we can say that x need to be nothing but minus b by 2a. And if x is equal to minus b by 2a, in that case we can say that equation a, from equation a, y will be equal to minus b square by 4a plus c, and this is basically the minimum value of a quadratic polynomial if a is greater than 0, and this value occurs when x is equal to minus b by 2a. Similarly, let's say if a is greater than 0, a is less than 0, then we will find maximum value of y when x plus b by 2a square multiplied by a is equal to 0 again. Why? Because this term, in that case, since a is less than 0 and this will also be greater than 0, so minus 2 into any number positive will always be less than 0. So we can say that this whole will be negative, and whatever value comes out from here, negative or positive, it will only decrease its value, because we are adding something negative in this value depending upon the value of x. So why not, let's make it the best we can, which is equal to make it 0, so that whatever value we get from here, that will be the maximum value. So that's what we will do. We will make x into a into x plus b by 2a square equal to 0, and therefore we can say that a is not equal to 0, so x plus b by 2a square is equal to 0, and so x is equal to minus b by 2a. And again maximum value is equal to the same value that we got, which was minus b square by ca minus b square by 4a plus c. So we can say that minus b square plus c is maximum value at x is equal to minus b by 2a. Here minus b square by 4 plus c is minimum value when, and this also occurs at x is equal to minus b by 2a. But these are two different cases. For example, if we have something like a greater than 0, then this case is applicable. But if we have a greater than 0, then we have the minimum value. If a is greater than 0, then we do not have any maximum value, but we have a minimum value. But if a is less than 0, then we have a maximum value. Now we will use this concept to solve these two equations. So before solving it, we need to write the value of corresponding a, b, c. So here we have x square minus 4x plus 7 is equal to ax square plus bx plus c. Therefore we can say that a is equal to 1 from coefficient matching of both LHS and RHS. B is equal to minus 4 and c is equal to 7. Now since a is greater than 0, a is greater than 0, therefore we will have here minimum value. Okay. Now minimum value occurs at x is equal to minus b by 2, which is minus of minus 4 divided by 2 into 1, which is equal to 2. So now there are two approaches. Either you put value of x is equal to 2 in this equation, or you directly write minimum value is equal to minus b square by 4a plus c, which is nothing but minus b is minus 4 square by 4a. A is 1, so 4 into 1 plus c is nothing but 7. So this gives us minus square, 4 square is 16, so minus 16 plus 4 plus divided by 4 plus 7, and therefore we will have here value equal to minus 4 plus 7, which is equal to 3. Look at this question, students. Here we have to find the maximum value, since we know that here a is equal to minus 1, b is equal to 8, c is equal to minus 11. Now since a is less than 0, this implies maximum value can be found at x is equal to minus b by 2a. So put x is equal to minus b by 2a, which is minus b means minus 8, 2 into a is minus 1, which is also equal to 4. Now maximum value will be equal to minus b square by 4a plus c, which is equal to minus b square is here 8 into 8, which is 64. 4 into a is minus 1, and plus c is basically minus 11. So this will give us minus 64 divided by minus 4 minus 11. Now minus gets cancelled. This cancels 16 times. So 16 minus 11, which is 5, is the answer. So I hope now you have a very clear idea about how to proceed in such questions where we need to find minimum or maximum value of any quadratic polynomial. There are only two cases. If a is greater than 0, then it will always have a minimum value. If a is less than 0, then it will always have a maximum value, and maximum value and minimum value both appears at x is equal to minus b by 2a, and value is equal to minus b square by 4a plus c. Thank you everyone.